All right, here's another video on undetermined coefficients. So the differential equation that we're after this time is dy dt equals 3y plus 4t. And I want you to stop and think about this. Is this differential equation separable? We know that separation of variables is oftentimes the easiest way to solve a differential equation. So, question: can we write this differential equation in the form dy dt equals some function of y times some function of t? Can that happen? So put me on pause, think about it, ponder, talk to somebody, play with it, and when you come back, we'll discuss. All right, so now that you've thought about this, the answer is most certainly no. You can't actually rewrite this right-hand side as a product of two functions, one of each variable. And so separation of variables is out the window. We can't use it, unfortunately. Right? But that's okay, we have other tools. This is still a linear differential equation, and so I can observe that I can break this into a homogeneous differential equation. So dy dt equals 3y, and a non-homogeneous differential equation which is the original, dy dt equals 3y plus 4t, which means that this 4t, this plus 4t, is the non-homogeneous piece. So we're going to use the method of undetermined coefficients. So the first thing we're going to do is we're going to solve the homogeneous differential equation. So I'm going to write this y with a subscript HOM for homogeneous. And pause and think about this again. How would you solve this homogeneous differential equation? Put me on pause, play with it. Now hopefully you got the exact same solution. You can get there by separation of variables, you can get there by making a guess. There's lots of ways you can do it. The particular solution needs to have the same functional form as our non-homogeneity. So I'm going to say y particular, in this case, needs to be a linear function, because the function that we have in the non-homogeneity is a linear function. So the most generic linear function I can think of is going to be c1 t plus c2. So think of that like a slope-intercept form, right? And since we need subscripts here, I'm going to put a c0 on this one. Okay, now given that this is a linear differential equation, my analytic solution is my homogeneous solution plus my particular solution. And again, please take note of the notation I'm using here. I'm using homogeneous and particular as the subscripts instead of hats and bars and whatever else you might have seen in the past. So in this case, that means that y is equal to c naught e to the 3t plus c1t plus c2. The rest of undetermined coefficients is now just detective work. We have the differential equation, and we have an initial condition, which I haven't given you. I'll give it to you in a second. Those are the things that we get to use in order to find the undetermined coefficients, the three coefficients, c naught, c1, and c2. So if you want to break this into steps, the things that we've done here, like step number 1, we found the homogeneous. Step number 2, we wrote down the particular solution. Maybe we'll call this step number 3, we wrote down the analytic solution. And step number 4 and 5 and 6 and 7 and whatever, we're going to use all the information. So let's say, for example, that y of 0, the initial condition is, let's say, 2. Okay, and we also know, I'm going to rewrite it, y prime is equal to, let's write down the original, 3y plus 4t. Okay, those are the things we get to use in order to do our detective work. Okay, so let's use them. So if I use the initial condition, right, I'm going to put 0 in for all the t's. So I've got 2 equals C naught times 1, or I'll be very explicit, times 1, plus C1 times 0 plus C2. So that tells me that 2 is equal to C naught plus C2. Okay, so I've got one equation that relates a couple of the coefficients. Now let's use the differential equation. Now for the differential equation, if I put the homogeneous solution in for y, then I know that this part of the differential equation will be automatically satisfied, because that's the solution to the homogeneous solution is the solution to the part that I just highlighted in green. So instead what I'm going to do is I'm going to put the y particular into the differential equation. And so if we do that, my particular solution, y particular, is C1t plus C2. And if we put that into the differential equation, the left-hand side is, let's see, the derivative of y particular is C1 equals 3 times C1t plus C2 plus 4t. So to be abundantly clear here, that is y particular prime. That guy is y particular. And this whole thing is y prime equals 3y plus 4t. So notice I just replaced the y's with the particular solution. But now I just get to do a little bit more detective work. So nothing too crazy here. C1 equals 3c1t plus 3c2 plus 4t. And a little bit of rearranging here. So let's see, I'm going to have 0 equals 3c1 plus 4 times t plus 3c2 minus c1. Right, well now this linear function has to be equal to 0 at all times. This equals 0 has got to be true for all t's. So that tells me that 3c1 plus 4 is equal to 0. And it tells me that 3c2 minus c1 is equal to 0. So we got two equations and two unknowns. Well, so that tells me that c1 is equal to negative 4/3. Tiny little bit of algebra there. And so 3c2 plus 4/3 is equal to 0. Well, that tells me that c2 is equal to negative 4/9. So I've got c1 nailed down. I've got c2 nailed down. And recall, I'm going to scroll back up here. I have a relationship between C0 and C2. So 2 equals C0 plus C2. Let's write it down. So 2 equals C0 plus C2. And so I've got 2 equals C0 minus 4/9. So that tells me that C0 is equal to 2 plus 4/9, which is equal to 18/9 plus 4/9, which is equal to 22/9. Okay, I have all my pieces. So the solution to my differential equation, 22/9, e to the, let's see, what was my rate? I forget. Let's come back to it. Way up here. There it is. 3, e to the 3t. Plus, now I've got my constant, or my linear term, so that's minus 4/3. So it's not plus, it's minus. Oh, shoot. Well, that didn't work out so well. Let's assume that's not there. Minus 4/3 t plus 4/9. plus negative 4/9. I'm sorry, the signs kind of lost me there. But there's our solution. That's our guy. Okay, so the steps are really kind of, calling this a four-step method is kind of ridiculous, but the steps are really get your homogeneous, get your particular, write the analytic solution, and then just do detective work to figure out where everything else falls. Use the differential equation and the initial conditions to do that detective work.